Could theoretical Planet 9 or Planet X be a primordial black hole? Researchers are proposing a way to find this out. By Brian Coberlane, University Today, it's on phys.org. There are 8 classical planets in our solar system, from the speedy Mercury to the distant Neptune. There are also numerous dwarf planets such as Pluto and Ceres. While we continue to find more dwarf planets, there are some hints that another large planet could lurk far beyond Neptune. And this is Planet 9 or Planet X, Nibiru, whatever, Wormwood. There are various names for it. Nemesis. The Planet 9 thought to be a super-Earth, about 5 times the mass of our planet, which would make it about twice as large as our Earth. But despite several researches for the planet, it has not yet been found. Maybe we have not found Planet 9 because it doesn't exist. Evidence for the planet is not very strong. It stems from a statistical analysis of the orbits of smaller bodies in the outer solar system. The idea is that the gravitational pull of Planet 9 causes the orientation of their orbits to cluster, but as others have pointed out, the observed clustering could be due to other effects. If Planet 9 exists, it's a bit odd that we have not found it. Several sky surveys are sensitive enough to see a planet of its size. It's possible that the planet is more distant than we expect or has a lower albedo, but observations are starting to rule some of these out. There is, though, a much more radical idea. What if Planet 9 has not been observed because it is not a planet? What if it is actually a primordial black hole? Primordial black holes are hypothetical objects formed during the early moments of the Big Bang, and if they exist, they could have the mass of a planet rather than a star. If Planet 9 is a primordial black hole, then it would be about the size of an apple. This would make it far too small and dark to find with our current telescopes. But since it would still pull on nearby objects gravitationally, there might be other ways to find it. One way would be to send a fleet of tiny space probes towards its predicted general direction. In a new paper, Edward Wheaton argues that spacecraft about 100 grams in mass could be programmed to transmit a regularly timed signal. If any of them get in the range of the black hole, the signals will be dilated by its gravity. The downside of this approach is that the spacecraft would need to time their signals with atomic clock precision, and there are currently no atomic clocks small enough to fit on a 100-gram probe. A different team has proposed an alternative in which the probes instead sent a simple signal, a high-resolution radio telescope measuring the shift of their trajectories. But a third team argues that effects such as solar wind would overwhelm any gravitational effects. All of this pretty wild speculation. If there is a planet lurking at the edge of our solar system, it almost certainly is not a black hole, which means it will be observed eventually. But sometimes in science, you need to rule out the wild ideas before you can find the right one. This is provided by University Today, and it's on phys.org. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.